All right, we're going to look at one more example of the integral test here, and we have the infinite series n to the k e to the negative n, and k is going to be a positive integer, and so we're going to make sure that that we can apply the integral test. So we're going to look at the corresponding function. F of x is equal to x to the k e to the minus x. This is certainly continuous, and it's the product of two positive functions on 1 to infinity, so that's good. And then we'll go ahead and take the derivative, so it's a product rule, so k, x to the k minus 1, e to the minus x, and then we'll have x to the k, and then e to the minus x, and then times negative 1 by the chain rule, so we went ahead and put the minus sign in right there. We can factor out a x to the k minus 1 and an e to the minus x, and so what we have left is k minus x, and we're interested in when this is less than 0. So again, x to the k minus 1 and e to the minus x, that's going to be positive on 1 to infinity, and so when the k minus x is less than 0, that's when k is less than x. So that's going to be good enough. Now, you know, the k could be something outrageous like a billion, and even though it's a billion, the first billion terms of an infinite series doesn't matter. It could be a very big number, but it's still a big number. It's not divergent. So this is good enough. We can still apply the integral test. And what we're going to do is we're going to go ahead and look at what the integral is going to look like. And we're going to do the tabular method, and to kind of motivate it a little bit, we'll pick a concrete number like 4 to do the tabular method on, and so we'll take derivatives of x to the fourth, so we'll get 4x cubed, and then 12x squared, and then 24x, and then 24, and then 0, and notice that we can write that as 4 factorial, and 4 factorial x is the last terms. Integrating e to the minus x will be minus e to the minus x, e to the minus x, minus e to the minus x, e to the minus x, minus e to the minus x. And then when we do the tabular method, it alternates between positive and negative. So we go plus, and then minus, and then plus, and then minus, and then plus. And in every case, it is going to be negative. Okay, so they're all going to have a negative. All of them will be negative. Now, generically, if we have x to the k, then k x to the k minus 1, dot, 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 k factorial x, and then just k factorial, and then the next derivative will be 0. And then integrating the e to the minus x, that's going to, oops, let's go back. That's going to alternate. So I'm not sure. This is kind of dependent on what k is, whether it's positive or negative. But it's going to have the same thing where each term is going to be negative when we do the tabular method. Okay. So now we'll go on to the next, and we're going to look at x to the k e to the negative x dx, and then we'll do a concrete example, x to the fourth e to the negative x dx. And so when we do the tabular method, so that's the limit as b goes to infinity, x to the fourth plus 4x cubed plus 12x squared plus, okay, so we had a little bit of an error here, so let me fix this. We'll bring that out. Plus, this next one was not 12x, it was 24x, and then plus 24. Okay. All over e to the x, and then we're going to evaluate that from 1 to b. Okay, just going to evaluate that from 1 to b. Okay, now this right here is going to be indeterminate form. It's going to be an infinity over infinity, and so what we got to do is we got to do the L'Hopital's rule 4 times. So we got a finite application of the L'Hopital's rule, and that's okay. And so what that limit's going to be is, it's not going to be 29 over. It's going to be a little bit bigger than that. But the important thing is if we evaluate that, it's going to be it's going to be finite. That's the important thing. So that's going to tell us it converges. Okay. So that's going to be convergent. So it would be 48 plus 12, 60. It'd be 65 over E. So that's what that limit should be. We're getting that from that lower limit. Now for the more generic one where we just got a k, it's going to be a similar setup. So it's going to be limit b goes to infinity, negative, and then it's going to be x to the k, k, x, k minus 1, blah, 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 k factorial x plus k factorial, and then all over e to the x. Again, maybe I didn't mention this, but remember e to the minus x is 1 over e to the x, so we're rewriting that there. Every term had an e to the minus x, so we factor that out, and then that goes to the denominator there. Okay. Now this here, we don't know what k is, but we will have a finite number of applications of L'Hopital's rule, and that'll be just fine. And after that, finite applications of L'Hopital's rule, what we're going to have is the top evaluated at 1, and so that may be a very big number, but it's less than 0, or less than infinity, excuse me. So it's going to converge to some finite number, and that's what's important. So that means the improper integral converges. Therefore, this infinite series that we had on the previous slide is also going to converge by the integral test.